Hello and welcome to Coding History 3D. In this video series, I'll be teaching you how all your favorite games from the 80s and 90s rendered 3D graphics, and how you can create those renderers yourself. This Kickstarter video is done in the style that I'll be using for the actual series, so by the end of the video you'll have a pretty good idea whether or not you'd like the rest of the series. In this video, I'll go over each of the 7 episodes that are planned, the rendering techniques covered, and what makes them so interesting. Episode 1. Sprite-based 3D Dungeons. These games, which were usually dungeon crawlers, were pretty popular before true 3D games appeared. Because the player moves from tile to tile, all the graphics could be drawn ahead of time and simply assembled on screen to show the player a 3D world. That meant low-end devices which absolutely didn't have the processing power to do actual 3D calculations could still make a game look 3D. One downside of this method is how easy it is to get disoriented because there's no motion when you do things like moving or turning. A lot of games added animated effects to help with this problem, with the motion helping to ground the player inside the world. I'll also be covering how to replicate these motion effects seen in games like Lands of Lore, Shin Megami Tensei, and Phantasy Star. As a side note, I recently discovered that these games are referred to as blobbers because you move your party as one big blob, which I just think is hilarious. Episode 2. Pseudo 3D Racers. Although Outrun is the best known of these racers, it's certainly not the first or only racing game that uses this technique. It can't truly be called 3D because what you see tends to not have any relationship to any true 3D geometry as we know it. You can only race off towards the vanishing point, sometimes drifting to the left or right, but you can't actually ever turn around. While the underlying rendering technique is pretty easy because it doesn't actually relate properly to a physical space, other things like controlling the player's vehicle can be kinda tricky. There are a lot of ways to handle that, but I'll cover at least one approach to solve that problem. You can also do things like add height to the terrain, which is another thing I'll be breaking down. Episode 3. Raycasting. When Wolfenstein 3D hit DOS computers in the early 90s, it was like a whole new world opened up, even if it wasn't the first 3D game of its kind. id Software themselves had released Hover Tank 3D and Catacomb 3D before it, visually very similar games that were clear stepping stones on the way to Wolfenstein 3D. But Wolfenstein 3D is the game that's remembered by many for being their first experience with true 3D action gameplay. Not only did id nail the gameplay, the visuals were considered revolutionary at the time. A large part of that was a new technique John Carmack created for Wolf 3D called raycasting. Raycasting is conceptually simple, and for years has been a great entry point for people into understanding 3D rendering on a deeper level. In fact, raycasting wasn't created as an optimization at all. Carmack himself has said he created it to simplify overly complex spaghetti code in Hover Tank and Catacomb, getting rid of graphical glitches as a result. Episode 4. Mode7. One of the unique selling points of the Super Nintendo, Mode7 is most associated with the style of 3D that presents the world as a flat 3D ground plane that the player navigates, like in F-Zero and Super Mario Kart. Ironically, Mode7 by itself can't actually make things look 3D at all. Games that used this mode in order to present players with a 3D world actually had to combine Mode7 with another feature of the Super Nintendo called HDMA. In this episode, I'll deconstruct the affine transformations that make Mode7 work. Affine transformations are a class of 2D transformation that, when applied to a rectangular shape, always result in a parallelogram. Think scaling, rotating, and skewing a square image. I'll also explain how this was combined in the SNES with HDMA to turn these 2D transformations into the 3D planes it was most well known for. Episode 5. Voxel Terrain. What? No, not those kind of voxels. Definitely one of the more obscure things on this list. The only major title that I'm aware of that used voxel terrain was Comanche. Even though it didn't see wide adoption in commercial titles at the time, voxels were an interesting alternate branch of evolution in 3D. People experimented with voxels until the availability of hardware-accelerated 3D cards made polygonal 3D the clear winner. Voxel terrain is particularly interesting because it's great for outdoor scenes with terrain that has height. Nowadays, you just use a height map and draw the terrain as a mesh of 3D triangles, but that was pretty cost prohibitive for software 3D back in the day. Voxels were an excellent alternative that was performant, relatively easy to implement, and looked pretty good. Episode 6. Binary Space Partition Trees. Doom is remembered as the... No, not that Doom. The original Doom. You know, the one with John Romero's head on a pike. Doom is remembered as the first game that really created a believably 3D world. While you can argue how true that is, Doom is without a doubt one of the most influential games ever made when it comes to the evolution of 3D. Doom was a technical masterpiece, optimized in order to run well even on a 386, but the innovation we'll be focusing on is the BSP. BSPs, or binary space partitions, are a clever optimization that, no matter where the player is, can answer the question, what can I see? It does this in such an efficient way that high-octane action in a fully 3D world was possible for the very first time. In essence, you traverse the tree's graph to find the nearest wall to render, answering only the question, is our viewing location in front of or behind this node? BSPs are one of the trickier things in this series to wrap your head around, but we're going to take it one step at a time and demystify this very clever technique. Episode 7. The Build Engine. Duke Nukem 3D is remembered as a Doom clone. Unfairly so, because the engine Ken Silverman developed for Duke Nukem 3D, known as the Build Engine, actually uses a completely different technique for rendering 3D worlds than Doom did. Not only is this technique very clever in a less math whiz kind of way than BSPs are, it actually has several benefits over BSPs that didn't get nearly enough credit back in the day. The Build Engine renders its 3D scenes through a concept of portals. Instead of building a tree in advance that answers the question of what is visible from any location on the map, this engine treats the threshold between rooms in the map as a literal magical portal that connects to another room. That way, all you need to do to draw the map is to fill in the portals until there aren't any left on the screen. This technique allowed the Build Engine to do things the Doom engine just couldn't. It could show a live preview of levels inside its editor, or have bits of a level that could move side to side rather than the more limited up and down available in Doom. So, that's all 7 episodes. You might ask, why preserve this knowledge? Even though many of the techniques used for these games are outdated in modern contexts, there's still a lot we can learn from them. For example, raycasting is still the easiest way someone can get started on understanding 3D rendering without using something like OpenGL or DirectX. And many of the other techniques are still occasionally being used for games today. Here's a small sampling. While sharing this information is important to me personally, several people have reached out to me during the planning of this Kickstarter. They told me that they think preserving this knowledge in an easily accessible package was important to them too. If you feel the same way, or if you just want to be able to write your own Doom renderer, please help make this project a reality. I think together we can make this series a reality. Thank you.